All right, so this last video on 12.1 is really just about different practices and some more examples. So we're going to be looking at the probability of different events, multiple actions, repeated actions, everything that we've kind of been working on. So let's start out. What is the probability that you draw I'm going to say 6 or 7 from a standard deck of cards and making it a little bit more interesting? So, or we add. When we use the word or, we're going to add probabilities. So what's the chance we get a 6? Well, there's 4 6s. There's from the 4 suits, so 4 out of 52. Or a 7, there's 4 7s. So there's an 8 out of 52 chance, or a 2 out of 2 13th chance. About 15.5%. This next one, in a school, there are 123 students with brown hair, 78 students with blonde hair, and 31 students with red hair. That is a lot for red hair. Maybe this is a school in Ireland. But I tend to do this. I tend to write down the information they give me. So I want to know that the probability that a student chosen at random has blonde hair. So that's 78 out of how many? Well, if we total up all of the students, we get 232. So 78 out of 232 have blonde hair, or 39 1/16 or 0.336. What is the probability that if you flip a coin 5 times, you will get heads every time? So that gives you a lot of opportunities. It could be heads, tails, heads, tails, heads, tails, 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 tails. There's so many options. So there's 2 options every time. So you flip that one coin, flip it twice, 3 times, 4 times, 5 times. Those are all the options. So there are 32 possible outcomes when you flip a coin 5 times. Now, the fact that they're all heads, only one possible combination has it with 5 heads. So it's a 1 out of 32 chance, or a 0.031. What is the probability that when you roll 2 dice, the sum is a prime number? Well, there's a lot going on there. What are prime numbers, all right? Well, the sum goes from 2 to 12, so we only care about the prime numbers in that case. So there's sum of 2. The sum could be 3. 4 is not a prime number. 5. 6 is not. 7. 8 is not. 9 is not. 10 is not. 11. And 12 is not. So my sum, what's the chance that my sum is a prime number? So it could be 2, or 3, or 5, or 7, or 11. Well, if it's a 2, only if I roll a 1 and a 1. So there's one possibility that the sum is 2. 3, I could roll a 1 and a 2, or a 2 and a 1. 5, it could be a 1 and 4, a 4 and 1, a 2 and 3, a 3 and 2. Sorry about that. There's 4 ways it could be 5, 7, 1, 6, 6 and 1, 3 and 4, 4 and 3, 2 and 5, 5 and 2. So there's 6 possibilities there, and 11 can only be 5 and 6 and 6 and 5. So there are 1 plus 2 plus 4 plus 6 plus 2. There are 15 outcomes where the sum is a prime number, but how many outcomes are there possibly? Well, each die has 6 possibles, so there's 36 possible outcomes. So 15 of those give you a sum of a prime number. I know it's 0.4, but I think it's 1.1. No, 1.6 or 1.7. Let me close my door. All right, let's take the probability that you'll get at least a 75 on a test with 4 questions. So at least a 75 would mean 75 or better. So how many possible outcomes are there? Well, you get the first one right or wrong, the second one right or wrong, the third one right or wrong, and the fourth one right or wrong. So there's 16 possible outcomes of how you could take this. 16 possible outcomes of how you could take this this quiz. I want to know how many of those would give you at least a 75. Well, you could get 100. So you get all 4 of them right. You could get just the first one wrong. You could get just the second one wrong. Just the third one wrong. Or just the last one wrong. So there are 5 ways that you could take this test and get at least a 75. So 5 out of 16, or 0.313. All right, here we have a spinner. We're going to assume these are right angles, so this is a quarter, this is a quarter, this is a half. So a spinner is spun 20 times. The table shows the results. For which color is the experimental probability the same as the theoretical probability? So theoretical and probability, that's in part 1. Theoretical versus experimental. Just because you say something should happen so many times doesn't mean it will if you actually experiment. So if I spin it 20 times, if this is half, 10 of them should land on A. 5 should land on B, and 5 should land on C. That doesn't always happen. So here, this is the theoretical probability. This is the experimental probability. The theoretical probability of A is 10. In actuality, we only got 8. So it's greater in that case. The theoretical probability that we get B is 5. The experimental is 5. So in that case, the experimental is the same for both of them. So that was the question, which one is the same? And then the theoretical probability that you get a C is, is less than. So I said we'd get 5. We actually got 7. So the theoretical was less than the experimental probability. So it's that's how those compared. You still add up to 20, it just didn't happen the exact way the theory would say it did. And lastly, we have a very common shirts and pants question. So let's say you have 5 blue shirts, 3 red shirts, 2 blue pants, and 1 red pant. What's the probability that your outfit will be matching? Well, how many possible outfits are there? You have 8 shirts in total. You have 3 pants to choose from. So that's 24 possible outfits. So how many of those are matching? So a blue shirt and a blue pant, a red shirt and a red pant. Well, how many blue outfits are there? Well, I could have blue shirt 1 with the blue pants 1. That same shirt with the other pair of blue pants. I could go to shirt 2 with pants 1 and shirt 2 with pants 2. Now, I could list them all out, and that would take a long time though. But if I have 5 blue shirts and 2 blue pants, so there are 10 blue outfits. That might save you some time. So the red outfits, I have 3 shirts, but only 1 red pant. So there are only 3 red outfits. So out of these 24 possible outfits, 3 are red outfits, 3 are red matching outfits, 10 are blue matching outfits. So 13 out of the 24 are matching. So there's about a 54% chance. All right, and extra credit to the first person that emails me the exact timestamp of when my dog started barking in this video. And now please do your homework.